Hello, everybody. Today I want to speak about measuring complexity in our Python projects. And once more time, billion thank you to Extreme Python and for organizers. I speak on this conference the second time, and I'm very proud of it. And I can see this is one of the best organized conferences, online conferences. Thank you. Okay, let's go. Measuring complexity. Before I go to topic, probably I should say a little bit about me. Who I am? My name is Maxim. I'm more than 29 years in commercial software development. 11 years I work strictly with Python, and together with 9 years I work together with reactive front-end frameworks. Also, I'm a mentor for free for developers on AWS.org, and last 2 years I perform around 200 sessions. It means every 3 days I made one session with a developer. Okay, by this QR code you can achieve this presentation and whole code which will be presented in this talk. And also, I should say special thanks to my family for the support, because complexity is not only in code, and family helped me reduce the mental complexity. And this talk also exists thanks to people behind the scenes. And also, I should say thank you for my children who created illustration for all my presentations last 3 years. And thank you, Mark and Maya, for that. And right now, I should say the big disclaimer about all this topic. All talks about complexity is pretty subjective, completely subjective, and we don't have any clear objective metrics. And this is a problem. And you can see some mentions or some opinions like objective opinions, but not these opinions is also subjective. I will speak about Martin Fowler or any other author. It was also subjective opinions about complexity. I hope you understand. Okay, complexity. What is it? There is it, why it happens, and so on. We have in projects different types of complexity. We have accession complexity, structural complexity, cognitive complexity, accidental complexity. What is it? Technical complexity, essential complexity. This complexity present in your projects as is. If you choose this algorithm, you have this complexity level. If you choose other algorithm, you have other complexity level. And it exists at least, it cannot appear suddenly or disappears, it exists. And sometimes we can describe this complexity, or we can measure this complexity through big O notation, because big O notation it shows us mathematical complexity, and it's somehow aligned with technical complexity of parts of our code. And also the famous measurements, Maccabi index, probably this index, everybody knows. Okay, for example, on the left side, you can see Fibonacci metrics, Fibonacci functions to calculate Fibonacci numbers, and this is linear complexity, and on the right side we have we have function to measure Fibonacci numbers through recursion. And you can see this is two different algorithms which performs the same. And on the first glance, you can say the left side is better. But let's go further, because sometimes the right side is much more effective. We can see it later. But of course, the left side with O von n is much more, much less complex, for example, for time. Okay, structural complexity. What is it? Structural complexity grows with relations between parts of the project. If you have more than one part, you have automatically structural complexity. If you add new part, the structural complexity grows. Also, structural complexity reflected applied programming patterns, project organizing, and so on. If you have a strict project design, probably you can keep growing of structural complexity. But all developers in your team should follow this strict project design. How it grows faster? For example, by premature optimization, it grows faster. If you break Yagni pattern design or programming design, also structural complexity grows. Sometimes I see different projects with over-engineering because the developer wants strict follow solid pattern or rules, and in this case also structural complexity grows. How we can measure it? We can measure measure structural complexity, or we can calculate structural complexity with maintainability index. We can calculate how many classes, methods, or functions. We can also calculate dependency index. Dependency, how project part of projects depends each from other. For example, this is example from huge healthcare project, and you can see different lines of imports. If I collapse this all in my code, you can see we have around 200 import lines in one file. This is incredible, and it should not be. This is it shows the high structural complexity or high quantity of dependency in this file. If something is broken, we have many chance to break functionality of this in this file, because it depends on huge quantity of objects from whole project. But this is, you can see, it's around 168 imported objects in 130 import lines. But in famous frameworks, you can meet it also. In Django, you can see around 100 imported objects in 6 lines, or in FastAPI, you can see around 70 imported objects in 20 lines, and so on. This is simply idea what this part in projects has a problem. A complexity is concentrated there. Cognitive complexity. Cognitive complexity reflect readability or reflect understandability or ability to mentally reproduce logic, which I read it right now. And it will be corrected or reduced by code style guides, correct commands, and documentation. Cognitive complexity is strictly human-oriented metric. Because, for example, generative AI, they don't see this problem. We can measure cognitive complexity with Halstead metrics, with Sonar cognitive complexity index. We can measure it with dog coverage. Beautiful example from one project. This is a small function. This function collected managers who should get their emails. And you can see this is an old Django project with Django version 1.4. The managers get, I collect all managers which have permission special permission. And I create a dictionary which should be returned. But what happens on the next lines you can see? If I don't find any managers with permission, you can see on the line number 9, I take full managers from this object. And it's completely not clear, and nowadays, even me, cannot answer why. If we don't have any person with permission, and we takes, in this case, all managers. Without documentation, you cannot understand. And even me, and this is an example from cognitive complexity. We don't understand why it's written and why it works so. Okay, and the last part, this is accidental complexity. Accidental complexity happens in development. If you don't do anything with code, you don't, your accidental complexity not grows. And it happens because you have some compromises in between parts, they not aligned. Usually accidental complexity grows if you transform your MVP project to permanent solution. And accidental complexity can be reduced by strict schema, by specification. For example, we can see development with truth specification. And also accidental complexity grows or appears in AI-assisted projects or in startups. And its growth and you cannot feel how it grows. We can only measure the complexity somehow, and we can say, aha, accidental complexity probably in this part it grows. And how we can measure it? We can measure unusual activity and code churns in local places, and we can say there is concentrated accidental complexity. Okay, let's go. Example. This example from previous slides, Fibonacci function with recursion. We compute Fibonacci numbers with recursion. And somehow came somebody and says, this is a pretty long and heavy function, we should do something. And instead of changing of algorithm, simply the senior developer adds caching and transform the computation complexity, made computation complexity lower. And in this case, this is accidental. There, accidental complexity grows because instead of changing algorithm, we simply wrap wrong written or complex algorithm with some wrapper who improve some unwanted behavior. This is, my opinion, example from accidental complexity. Metrics of complexity which can help us to measure it from ambiguous to rare. Lines of code, single source lines of code, or logical lines of code. This is our general metrics. Lines of code, simply code which you have in a repository. You can say, we have 5 billion lines of code, for example, Dropbox said. These numbers is to share it for all, but it's enough because source lines of code, this is cleaned source code from commenters, from empty lines, and exactly these metrics used in any other calculations. But in reality, you need only logical lines of code. It's code itself. In reality, it's a small part of your code base. And we can see it later. It's not comparable with source code and code itself. Okay, for example, I write my own library, and you can see in Fast API, in one file, we have more than 4,000 lines of code, but in reality, code itself takes only takes only 400 lines. Any other things, this is only things which help us to organize the code. And okay, we can compress this file in 10 times, and nothing will be broken. Less code lines, less tests, and so on. Next, and okay, lines of code or source lines of code quantity can say us this is a complex thing or not complex thing. In compare a file with 10 lines of code and 4,000 lines of code. You can compare. Okay, but we can find more worse things. Sorry. Okay. Somebody write in chat, but I don't understand well. Okay. Worst things we can find also in Fast API. For example, we have one file which can be compressed in 28 times. It's incredible. Okay. Next. Next. And if I have one example how coding agents can create the code and how human can create the code. This is the same functionality. It's around the same lines of code, but if you can see the artificial AI agents write the better code if it works than humans, and I like it because right now I have a tool which works better than me itself. Thank you. Okay, then next, Maccabi index, which can help us to measure technical complexity. Maccabi index is interesting. They reflect quantity of decision points in my code. Maccabi index gives me penalty for every logical structure. And sorry, but Maccabi index, if I want to reduce it, it forces me to use less effective construction to achieve better Maccabi index. But interesting is Maccabi index you can use in prompts for coding agents. For example, write the code with small Maccabi index, and it's a climatic complexity index. And usually AI agents can do it and understand it. And I like use this part of prompt, at this part of prompt in if I work with agents. Okay, dependency, how many class functions you have in your code can show you technical complexity or structural complexity. For example, I try to calculate what happens in Django, and in Django we have around 2,000 classes and 1,000 functions. And for example, query set in Django, this is the heaviest class in whole framework, and in compare XML, we have heaviest function, which also included function composition. It means function declared in functions. And we can see programming paradigm of our Django framework is around 60% class-based and 40% is function-based. It's interesting, I measured the last version of Django. In previous version, it was much more function-based, oriented framework. Okay. Important things, we should not measure it in PyTest or unit test parts of project. It should be excluded from measurements. We can discuss it why. Okay, dependency index. This is important part of complexity measurements. You can see I measure the huge healthcare code base. It's around 2,000 files, and you can see in one file we import. It's around 200 objects. We import in one file. 200 objects. If you can understand, it's around 10% from whole project is imported in one file. It means to break functionality in this file, it's very easy. Because simply in one of these imported objects, in one file, these imported objects is defined. I can make something wrong, and the end file simply not works. Okay, problem is the dependency index. Dynamic imports in Python is able to do it. They are not included in these metrics, and it's pretty hard to include it, but I try to include it. Also, we can visualize dependency index, for example, with Nano API visual maps. You can see we have pretty bad binded structure and some independent applications in project. And this is the black part. It's pretty hard to change or to refactor. Okay, Halstead metrics as one of the best metrics which I want to present. Reflects readability of code as text, gives small penalty for name, get hard penalty for statement, get hard penalty for operator. In this case, if in new version of Python you get the more new operators and start to use it, automatically you increase complexity in your code. And the Halstead metrics to reduce, it forces us to apply dry pattern on maximum. Okay, Halstead metrics from coding agents with humans, I can say AI generated code have bigger vocabulary. It means generated AI created more different names than human, but I think it will be changed soon. And but right now, human write a little bit better code than AI if we measure it with Halstead metrics. Okay, cognitive complexity from Sonar. It's a fake. We can speak about it. It forces us to write a plain code, but it's not adopted for Python. It's calculated wrong. I created myself the code which calculates cognitive complexity, and I can show in discussion why I think this is a fake and it works wrong for Python code. Maintainability index. This is the famous fake in whole complexity measurements in our history. It's created in many years ago. And you can see Halstead metrics included in this formal. And it means if you add more words in code, it grows. It means if you add type hints, you automatically increase, you automatically reduce ability to maintain your code. The next is source lines of code also goes in this metrics. And it means if you use formatter like black or like rough, you automatically increase complexity in your code and reduce maintainability of your code. But problem is in this part, because you can see sinus. And what it means? It means you can write the same code, but with comments, you can change maintainability index. It grows, but it goes down, it grows and goes down. And it's implemented by Radon, SonarQube, Microsoft Visual Studio, Willy, Project Codemeters. It means this metrics is completely without, created without understanding what it's measured. But okay, you can use it. Okay, and I don't know how many time I have. Michael, can you write me how many minutes I have? 2, 3, 5 in chat. Okay, 2 minutes. Okay, accidental complexity. How we can measure it? We can measure it with churn metrics. For example, you can see this is the whole codebase, on this screen, and you can see how many changes in every file was made. And you can see on the right side of this graph, of this schema, you can see the files which contains high accidental complexity, because we did too much changes in this file. Exactly this part of your code should be changed or maintained or tested on 100%. Any other files, it's not too important. Don't forget about Pareto rule. Okay, working with complexity, like a final step. At first, working with complexity works only if you add requirements for complexity handling on the business level. If you do it something like voluntary, it not works. Working with complexity should be added in KPI of your project. The next step, you should define the refactoring hot zones. Exactly what I say. Find the worst accidental complexity places. Takes only 20% from that, and it's give you 8% results for that. Results how you can reduce accidental complexity. And the last part, you should watch how complexity grows. It means you should take metrics on start. These metrics should be only relevant points, and after sometimes you should take the new metrics, and you can see how the metrics grows, complexity grows or not. And if it grows, you can see in which places you should go to reduce this complexity. Only the one number give you nothing. It should be some measurements in between with time. Okay, recap. Last words about measuring tools. Radon not works with type annotated data classes. My issue you can find in Radon repository. Sonar Cloud, due language agnostic, not works well with Python code. Aikido, code quality measurements not works. I checked it last Friday. All services built on Radon is Xenon, Willy, CodeClim, and Codachi. They works not correctly. That's why I created my own tools which measure all metrics which I already say. Complexity recap at all. Complexity, it's normal. You can find complexity only if you compare what was before changes and after changes. One number give you, one matrix give you nothing. And every complexity and every talks about complexity is subjective. Try to find your own way how you fight with your complexity. You can try it at home. You can choose a project. You can find a zero touch depth zone. These files which should be tested have 100% test coverage, and you can find complexity points or complexity metrics for these files. You can find the file with biggest complexity metrics and try to improve it. And after that, compare the metrics after. Enjoy and repeat. Thank you. Time to refactor questions to answers. My name is Maxim Danilov, and this QR code leads to all code examples, slides, and so on. On the next slide, I put the links on the sources which I use to create this presentation and many other presentations about complexity. Thank you.